Welcome to today's math exploration. We are going to tackle a fascinating integral problem, that is integral 0 to 1 square root of minus ln x dx. We know that integral of ln x dx, that is x ln x minus x plus c. We know this. But here this integral seems challenging due to the negative sign and a logarithm under square root. So traditional methods won't work here. To crack this problem, we will employ the gamma function. Gamma function is a powerful tool in mathematical analysis. So the gamma function is denoted as gamma of z, and it is defined as integral 0 to infinity t power z minus 1 times e power minus t dt. This function extends the factorial to real and complex numbers. It has few properties, that is gamma of 1 that is equal to 1 and gamma of 1 by 2 that is equal to root pi and gamma of x plus 1 that is equal to x factorial and another complex factorial gamma of x plus 1 that is equal to x times gamma of x. For example, gamma of 12, so the value is this, we can use this property, that is gamma of x plus 1 that is equal to x factorial. So this 12 we can write in terms of x plus 1, that is 11 plus 1. That here x is 11, so that is equal to 11 factorial. So gamma of 12 that is equal to 11 factorial. So like that you have to use the properties. And let's come to the question. We have integral 0 to 1 square root of minus ln x dx. Here we have under root of minus ln x. To simplify this, let us consider t equal to minus ln x. Here minus is nothing but minus 1 times ln x. So ln x is a natural log, so that means it has base e. So that is equal to t. Now recall the one of the logarithm property, that is log of a power m. We can write this as m times log a. That means whatever in the power, it comes and stay in front. So now our minus 1 times ln x, it is in the form of m ln a. So now we have to write in terms of log a power m, that is ln. So here m is minus 1. So just write x power minus 1 with base e, that is equal to t. Now recall one more logarithm property, that is log of a with base e, that is equal to some value. Then we can write this as a equal to base power that value b power n. Similarly, we can write our expression x power minus 1 equal to base power, our base is e, so e power t. But we want only x value, not x power minus 1 value. This x power minus 1, it is nothing but reciprocal of x, that is 1 over x, that is equal to e power t. So then from here the x value is 1 over e power t. We can write this as x equal to e power minus t. If you derivate with respect to x, so then dx equal to, recall the derivative of e power x. Derivative of e power x, the formula is e power x only. But here we have a negative value in the power. So what about that? So derivative of e power minus x, the formula is minus of e power minus x plus c. So our derivative of e power minus t, it becomes a minus of e power minus t dt. So we found the dx value. Let's substitute back in our equation. We have integral 0 to 1 square root of minus ln x dx. This is our original integral expression. So we assumed minus ln x as t. So let's just write integral square root of t times dx is nothing but minus e power minus t dt. So just write minus e power minus t dt. The log x, if we turn into t, so we need to change the limits also. If x tends to 0, then t tends to infinity. If x tends to 1, then t tends to 0. So our limits are infinity to 0. Here we have a negative sign. To make it to positive, we need to change the limits. Then only it become positive. So that's why I am changing limits to up to bottom. 0 to infinity. This negative value we changed into positive. So root t e power minus t dt. Square root t, we can write it as t power 1 by 2. Isn't it? So 1 by 2, we can write this as 3 by 2 minus 1. When you take LCM, then you will get 1 by 2 only. So instead of 1 by 2, we can write 3 by 2 minus 1. Isn't it? So let's take instead of 1 by 2, just write 3 by 2 minus 1. Because we are trying to convert in terms of gamma function. Gamma function is defined as 0 to infinity t power z minus 1 e power minus t dt. This gamma function is denoted as gamma of z. Here in our expression we have t power 3 over 2 minus 1 times e power minus t dt. That means our z value is 3 by 2. So our integral expression we converted into gamma function. Now we need to find this gamma of 3 by 2 value. Here let's recall the properties of gamma function. We have gamma of x plus 1, that is equal to x times gamma of x. Let's use this property. So that means this 3 by 2 we have to convert in terms of x plus 1. Gamma of 1 by 2 plus 1, which is same as 3 by 2. So we convert into x plus 1 form. So that means x value is 1 by 2. Now write x times gamma of x. That means 1 by 2 times gamma of 1 by 2. So that is equal to 1 by 2 times gamma of 1 by 2, the value is root pi. Then gamma of 3 by 2, the value is root pi by 2. So gamma of 3 by 2 is nothing but integral 0 to infinity t power 3 by 2 minus 1 e power minus t dt. The value is root pi by 2. Therefore, integral 0 to 1 square root of minus ln x dx, the value is root pi by 2. If you enjoy this content, don't forget to subscribe my channel. Thank you for watching.